All right. Hi, everyone. Welcome to today's demo. I'm Ryan, Director of Product Management here at Byos.
And I'm Jim Larita, Senior Solutions Architect or Engineer.
Today, we're going to be taking you through a platform overview of the Byos Edge Microsegmentation solution and walking through a specific use case around machine data capture within OT environments. So collecting data on the plant floor today or in your industrial networking environment has a number of considerations, all surrounding these sort of three themes, security, troubleshooting, and system maintenance. And I think there's just a bunch of questions that, manufacturing engineers, IT security people have about how data gets collected from a process wise on the plant floor and how that can actually be improved on its efficiency. So, from a networking perspective, how many machines are connected to the network? Are they wired or wireless on the plant floor? Do they have internet connectivity or not? And if they don't have internet connectivity, is that internet connectivity because it's blocked at the perimeter, or are those assets actually air gapped from the network altogether? Then we get into the types of devices. How old are the devices? Are they legacy machines? Do they have a lot of useful life left in them? Is this a rip and replace situation where, if we ordered new machines and that had better connectivity, would we be able to protect them better by installing newer softwares on them? Or are we happy with what we have, but we want to actually improve, their ability to talk to newer applications in the cloud without actually have to meddle with anything on those actual assets? Then we get into the more procedural steps. How is data collected from these machines on the plant floor? Is this a manual process where someone walks around with a USB stick, pulling the data off the machines and then going over to the engineering workstation? Are all these machines networked on the plant floor, talking to that local engineering workstation, or are they actually cloud enabled where the applications on the plant floor machines themselves talk to other cloud-based applications across the internet? How is maintenance and troubleshooting done? Are there access controls inside of the network? How does this scale across multi-site manufacturing operations? I could go on forever with considerations that these engineering teams and these networking teams have within the OT environment. Jim, was there anything that I missed there?
Well, yeah, so I think, some of the things that we need to talk about when we talk about security troubleshooting and system maintenance, like you said, is the access methodology. How are we going about doing this? Are we talking about contractors, remote contractors getting into the network? How are they getting into the network? Rhetorically, of course. Are they using VPNs, right? Or are we using VPNs as an organization? We know VPNs can be costly. We know they can be complex when you think about, network infrastructure, what type of hierarchical structure exists within the environment. And then I think you have to take into account that, VPNs aren't secure necessarily the entire time until that tunnel is established. There's a lot of naked data out on the network that could be sniffed. We're also talking about anonymity. VPNs are not going to necessarily ensure anonymity. So again, you have to think about these things. You have to think about legacy devices, like you said. Are these devices designed with inherent protections in mind? Do they already have inherent protections, or do they need some augmentation in order to provide those protections? So there's a lot more to it than simply the obvious, right? Are these machines even designed initially to connect via Ethernet to the network, or have they been adapted? Again, instead of, like you alluded to, instead of doing a full rip and replace, do we have the ability to put something in that's going to provide that protection, provide that access, and really make your life a whole lot easier as a network engineer or as an organization.
Yeah, that's great. So let's actually jump into what we're building here at Byos. I want to talk about our edge microsegmentation solution, the various aspects of our solution, the different concepts and nomenclature within the platform itself, and then we can dive right into a sample architecture and a demo. So from the highest level view, everything that we do here at Byos starts with our secure edge technology. This is the hardware that gets deployed in front of your assets, that cloaks your assets, making them invisible to the network. Basically, what we're doing is we're the hardened piece of communication interface between the asset and the rest of the network. We provide the route enforcement. We provide all the network security protections on the local network, both inbound and outbound, which we'll get to later, to isolate the assets from connecting to the network themselves, right? So if you think about a PLC controller plugged in directly to a switch on the network, now that controller is going to plug into Byos, and Byos Secure Edge is what's going to connect to the network on behalf of the asset. What we do then is we pair it with a cloud managed control plane. Now, this control plane is what lets you as the administrator or the IT person to push policies and manage these edges from a central place, right? Edges will get activated. They'll receive the policy from our control plane. That policy will have been established by the administrator, and then all edges that go into that policy group will receive the same policy set. Then within the policy set is determined how that edge routes to the outside world. And the third component of our solution is a secure software-defined network overlay that connects all edges together. This overlay is both isolated from the underlying local network as well as from the internet. And so what that gives you is the ability to say, this port and service resource on this asset in this site can talk to this other asset in this other site in this other zone granularly only on this port and at this time. So you get granular asset isolation, various different OSI layer access controls, and end-to-end remote management without ever having a packet that leaks onto the local network or onto the public internet. So it's super powerful.
Yeah, and to add to what Ryan was just saying, it essentially, when we think about the secure overlay, essentially what it is that is your segmentation methodology within the Byos environment. So that's going to facilitate, and we'll talk a little bit more about this in a few minutes, but that's going to facilitate local addressing within inside the microsegment itself. That's going to facilitate the separation or joining of different edges and ultimately the assets attached to them. And that's going to determine who can talk to who through that overlay network or within that overlay network. So if you think about conceptually traditional networking nomenclature and verbiage, if you think about VLANs, for example, or you think about routing, you think about subnets, this is quite literally where that sort of segmentation will take place. So you've got multiple zones with multiple edges within each zone, and you can quite literally, with a simple point and click, determine whether or not two edges can communicate with each other from different zones within that overlay, and whether or not the assets attached to those edges can communicate with each other. And if so, which port and protocol or which resource can they use to communicate? So it's really everything that you think of with traditional networking is there. It's all baked in. It's just a lot easier, it's a lot stronger, and it's a lot more powerful.
Yeah, that's great. And so let's actually dive into some of those terms that we were just using, right? So edges, those are the Byos Secure Edge technology, either our gateway edge form factor or our endpoint edge form factor. The assets, those are the machines that are connected to BIOS that are within the protected microsegment. Now, what happens is policy groups are what edges are assigned to. So, policy group 2 on the screen has 2 edges that belong to it. The policy groups determine the internal, the external networking settings, the blocking and filtering rules, and ultimately the zone membership. Like what Jim said, zones are layer 3 logical segmentation within the biosecure lobby overlay that have a number of different access controls, inbound access, outbound access, and then access for secure lobby guests. And secure lobby guests are layer 2 tunneled connections into the biosecure lobby. So that's a very high level description of the concepts that you'll see in our demo later. But let's get into it, Jim.
Sure. Thank you, Ray. So what we've got here is we're calling it our demo architecture. This is our base case. All right. And what we're looking at here on the screen is essentially a representation of what a network may look like or could look like with regard to some remote users, as you can see above with the remote laptops connected to the internet, a perimeter firewall, right? We're all familiar with what a perimeter firewall is. Some sort of network infrastructure existing below that perimeter firewall that is facilitating connectivity and traffic management. In this particular case, we're looking at a wireless access point. This wireless access point is representative of a ISP or an internet service provider. And then beneath that access point or that piece of infrastructure equipment are some assets or endpoints, if you will. So we see we've got a cell 1 laptop, we've got a cell 2 laptop. I think you can see we're talking about segmentation here in a few minutes. An Ethernet switch and an IP camera to provide some kind of security. Pay particular attention right now, though, to the IP addresses that have been issued to those assets. We have a 192.168.1.x network. We're going to just assume the norm here that there's a 24-bit mask, but we see a .1, a .2, a .3, a .4. Okay, pretty basic stuff. This is some of what we're all familiar with, right? A network behind a device, an infrastructure device behind a perimeter firewall with typical non-routable IPs. So now we're going to add a little bit more to this layer of complexity. So what you'll notice now is there's a couple of BIOS devices on screen, and some of the lines and connections have changed a bit. So you'll notice in the top left-hand corner, you'll see a laptop, and you'll see a little BIOS square with a little nub on that. Well, that's our endpoint edge, and that little nub is a USB-C port. That USB-C device will plug into that laptop, into that asset on a public network or on a private network. And now that BIOS device is sitting in front of or adjacent to that asset and is now going to communicate on behalf of that asset. Furthermore, if you look down inside the local area network or the LAN, you'll see that those assets are now no longer connected to that piece of network infrastructure equipment. You will notice that on the left-hand side, for cell 1 laptop, there is now a BIOS gateway edge sitting between that piece of infrastructure equipment and that laptop. You'll also notice that laptop's IP address has changed. It is no longer 192.168.1.1. Now what's happened is that BIOS device has probably adopted that 192.168.1.1 address from that ISP or internet service provider access point. And now the BIOS device has issued a microsegmented address to that laptop. So the BIOS device sits in front of that machine or that piece of equipment. The BIOS device grants that device an IP address and then speaks on its behalf, essentially, to the rest of the network. If we shift over to the right, you'll notice we've got 3 pieces of equipment that still exist. We've got a laptop, we've got an Ethernet switch, and we've got that IP camera again. You'll notice there that those IP addresses have changed as well. Now, instead of a 10.10.2 network, we see that that's a 10.10.4 network. So again, it's Class C network, 24-bit mask. That third octet has changed, right? So in essence, what we're looking at here is we're looking at two smaller LANs or microsegments, one consisting of one laptop and one consisting of a laptop, a switch, and a camera. But we're not done yet. Next, what we're going to do is we're going to factor in the zones and the policy groups that Ryan alluded to on the last slide. And don't worry, we're going to expand on these in a moment. But what we're looking at here now is you'll notice there's a new address that's been added to the fold called the BIOS IP address. The BIOS IP address is actually the portal from which to enter or exit the zone. Okay, so that is your, if you think of traditional networking parlance, that is your physical segment or your subnet, right? So that would be, in the traditional routing world, that would be your default gateway. And that's really the best way I can come up with to describe what that BIOS IP address. The address itself is representative of that zone that it's in, but that also means that's in that zone within the secure lobby overlay.
Yeah,
So,
Jim, I think that
yeah.
I think that's an important piece to distinguish here, right? Is that, you know, the BIOS IP is the default gateway for the assets inside of that edge in the microsegment within the overlay, right? But when you look at that local network on premise, on site for that access point, any other device connected to that is not a part of the microsegment, that is not a part of the zone, actually has no visibility or no clue as to that actually existing, right? If someone's trying to fingerprint,
Yes.
sniff, enumerate the BIOS secure edge devices within the local network that they exist on, they're not going to get anything. There's going to be no response, right? So that's the key difference here, is that this logical segmentation of the zones is purely a construct in the sense of, or in the perspective of those devices on the local network. They have no idea that they're there. Jim and I know that they are there because we're the administrators of the BIOS management console.
Exactly right, Ryan. So to expand on this a little bit, what we're going to focus on here for our demonstration that's going to happen in a moment is we're going to focus on the Lab 1 zone, which is in the top left-hand quadrant of the screen that we're looking at here. And you'll notice that that BIOS device, or that BIOS IP, has an address of 10.20.30.15. Again, that is the portal or gateway or default gateway for that particular asset attached to that edge within that zone, following whatever policy group it's adhering to. And that's going to be the controlling mechanism for entrance and exit to that device within that zone. And then in the bottom right-hand quadrant, we see Lab 2 zone. Okay, and you'll notice again, here we have a BIOS IP address of 10.20.40.9. Now you'll notice we didn't depict this on the laptop, but you'll notice that down below inside that microsegment provided by or facilitated by that BIOS gateway, you'll notice that the laptop, the switch, and the camera are still maintaining that 10.10.4.x network. All right, so you've got the 4.97 for the laptop, you've got the 4.47 for the switch, and you've got the 4.72 for the camera. So when those assets, and I'll depict this for you live in a moment, but when those assets communicate with each other, so for example, if I try to log into this switch with this laptop, I'm still going to type 10.10.4.47 into my web UX in order to gain access to that switch because I'm local to it. However, if I want to communicate with that switch, foreshadowing, from this laptop up here in the top left-hand corner, I am not going to try to access that switch at 10.10.4.47. What I need to do, again, think switching and routing, think layer 2 and layer 3. What I need to do, in essence, is talk to the BIOS IP, or that secure lobby address of 10.20.40.9. So hold those thoughts in your minds, and I'm going to jump into the management console now, and I'm going to show you how this works. So let's real quick, I just want to show you guys what we're talking about here. So I'm going to use a filter with just my initials so I can focus in on my pieces of equipment that we're going to be talking about with that, with the slide that we just looked at. So you'll notice here there's JLEE, just stands for Jim Larita Endpoint Edge. You'll see that my BIOS IP address is 10.20.30.15. You will see that my policy group, which we haven't talked about yet, but Ryan alluded to a few moments ago, you'll see my policy group is called Gym Lab A, and there's my routing or internal routing scenario, which we'll talk about in a moment. And then you'll see that I'm a part of Lab 2. So if I jump back real quick to the slide, you can see Lab 2, JLGW2 or Jim Larita Gateway 2. You'll see the BIOS IP address of 10.20.40.9, right? So we'll jump back again, 10.20.40.9 for JLGW2. And then for JLEE, we have 10.20.30.15. So if I jump back to that slide, again, top left quadrant, there's JLEE, 10.20.30.15. So in essence, what we're trying to do here is, again, to circle back to the original intent of this particular demonstration, is we want to show how we're first protecting this asset down here, or these assets down here, but also how are we providing system maintenance or gathering telemetry data or syslog information from this device or this device or this device remotely. Okay, so there's a twofold agenda here: end device or asset protection, and maintenance of those devices, and potentially pulling some information from them. So I'll jump back to the management console here now. And now that we've got the addresses established, what I'd like to talk about first is reviewing the policy groups. So Ryan alluded to the policy groups a little bit earlier, but essentially what we're talking about here is for the secure lobby, when we talk about the policy groups, we're talking about naming them. We're talking about external network access. We're talking about which zone they're a part of. We're talking about which edges belong to those policy or follow it or adhere to those policy groups, and which zones those endpoint gateways or edges are a member of. And then we're going to talk about the internal network. So I want to pay particular attention to this one right here. You see where it says 10.10.4.0? Again, a little foreshadowing. You'll notice that 10.10.4.0, that's a network ID. If you remember earlier what I said about the routing scenario with subnets, right? This is where that's established as well. So again, I'm going to jump back to the slide real quick. And you're going to see 10.20.40.9. So in essence, when you think about zones, policy groups are acting as the DHCP server for the microsegment or internal network, and zones are acting as the DHCP server for how you access other zones or the outside world. So in essence, what we're talking about is we're talking about internal support and addressing, and then we're talking about external support and addressing. Okay.
Yeah. So Jim, how do we know if an edge is actually able to communicate with the secure lobby overlay?
Yeah, that's a great question, Ryan. So what we're going to do now is actually look into the policy group, and we're going to talk about the details of the policy group. We're going to talk about which edges exist within that policy group. We're going to be looking at our internal and external network settings, and this is where we determine whether or not this edge and the assets behind it are going to be communicating through the secure lobby or not through the secure lobby. So let me take you through that right now. And you could see here, just on the initial policy detail screen, you could see the name of the policy group, Gym Lab A. You could see the name of the zone, which is Lab 1. You can see the IP or the network address of that lab or that zone, 10.20.30.0/24. All right, so we know that it's going to be a 10.20.30 address. Then we're going to look at the edges menu, and the edges menu is going to tell us which edges are following along or adhering to the rules issued by this policy group. Next, we're going to come and look at external networks. So if you remember a few moments ago, I said that for policy groups, the external network this is where we determine whether or not we're going to be speaking or be inside that secure lobby or protected by that secure lobby overlay. And you could see here, there's a number of different routing options or scenarios. For example, if we wanted to go with just raw connectivity, where we're not communicating through the secure lobby at all, we can choose something like option A, where we have just raw internet access or unfettered internet access and unfettered LAN access. Or we could go to the other end of the spectrum and we can completely air gap everything that's sitting behind that edge, and we can go with the no traffic allowed. A nice even balance or a solid balance of connectivity, including secure lobby protection, would be something like option D, which is what we've got selected here. And you could see with option D, we've got internet access, we've got secure lobby connection, we've got allowance of outbound traffic to the secure lobby, and we've got routing all traffic through the secure lobby. So in other words, we are inside the overlay here with all forms of traffic that we're using to communicate, whether we're trying to get to the internet, whether we're trying to talk across to another zone, whether traffic is inbound to us, is that traffic going through the secure lobby as well? So we've chosen the most substantial level of protection that we have available inside of the environment.
Perfect. So that's that's a layer 2 connection, right? The connection between the edge and the secure lobby overlay is a layer 2 connection. So that's great.
That's correct. Yeah, that's correct. Right.
And that's
exactly.
great. So now, like, if I'm thinking about the use case, how do I know that? So I know that my edge is connected to the overlay. How do I know that my edge can talk to another edge in a different zone within the overlay?
Yeah, that's a great question, Ryan. I'm going to jump right into that here in 1 second. I just briefly want to show the internal network settings, because I would like to show the audience where those 10.10 addresses have come from with inside that microsegment. So here, let's choose a different policy group here. Let's go with this one. And we're going to look at the internal network. So I'm going to jump back to the slide real quick. And you'll notice here, we've got the 10.10.4.97. I know I'm repeating myself. I just want to bring it back, around to make contextual sense. So we've got the 10.10.4.97, the 4.47, and the 4.72. So if I jump back to the management console now, you can see there's the 10.10.4 network. You can see there's the Class C mask. Right? There's the CIDR, there's the 24-bit mask, there's the network ID, which is the network is the 10.10.4.0 network. We can see there's right? So if you're following along, this is traditional IP addressing, traditional IP networking, right? We have our broadcast address, we have our host minimum, we have our host max, in other words, the first and last address within that subnet. And we have the number of available hosts, which is 127 in this particular case. So now, to talk about Ryan's question and show how we're allowing the cross-pollination or the cross-communication from zone to zone, we're going to go into the zones menu. And you could see here, we've got, I'm just going to choose lab. So we eliminate some of the extraneous information. And you could see there's lab 1. There's lab 2, and there's lab 3. So let's jump back again to the slides. There's lab 1 zone, there's lab 3 zone, and here's lab 2 zone. Remember, we're using these two zones to facilitate remote connectivity down into this zone and this microsegment to perform system maintenance. So let's jump back over again. And we're going to look here. We see here is lab 2 zone. So we're going to expand upon that. And we could see the zone details here, right? We could see the name of it and we could see the network ID. I think we've covered those topics ad nauseum. But now if I look at connections, right? This is where, when we talked about earlier, Ryan brought up the different topics of discussion with regard to edges and assets and policy groups and zones, et cetera, et cetera. Here's where the rubber meets the road. And I think this is a good spot to mention. When we talk about network segmentation, traditional networking segmentation, right? Switches and routers, we're setting up the routing table here. That's all we're doing. You could either refer to this as setting up the routing table, you could refer to this as setting up the VLANs. And we're now facilitating the communication between the two zones. So you'll notice here for inbound connections, in other words, for inbound connections to lab 2 zone, we see that we're allowing traffic from lab 1, which, if your memory serves, that's the lab with the laptop and the single endpoint edge. We're allowing inbound traffic from lab 3, which is on the slide, is that bottom left-hand corner quadrant, and from Matthias. So there's another zone that we're allowing inbound traffic to. Now, we also want to potentially allow outbound traffic from one zone to another. So we also have to ensure that we're allowing outbound traffic. So here's the inbound, here's the outbound, and you could see that we're allowing outbound traffic from lab 1 and lab 3, or to lab 1 and lab 3. So lab 1 and lab 3 can communicate into that zone, and lab 1 and lab 3 can receive traffic from that zone. And then last but not least, you could see the members. So this shows the policy groups that are utilizing this zone, as well as the edges that are impacted by this zone. And here you'll see, let me move this over a little bit so you can see what I'm talking about. There we go. So here you'll see for this particular zone and this particular edge, we can see the JLGW2 at 10.20.40.9. Remember, that's the gateway or portal to enter and leave that zone. You can see that my MAC address is listed. The serial number for my gateway is listed. You can see that I am the activator. That'll come in another session. The date of activation and the software version. So here's all the pertinent information for the 4 pieces of equipment, the 4 either endpoint edges, gateway edges, or a combination of the 2. You could see these are the 4 edges that reside within this zone. All right. And the policy groups that are dictating or mandating the controls that are applied to those assets.
Okay, so that's unreal. We've got so our edges are connected to secure lobby overlay on layer 2, right? We've allowed the interzone communications on layer 3, and now how do we actually facilitate access from that the switch inside of lab 2 zone to the endpoint edge and the laptop in lab 1 zone?
Yeah, that's great spot to go next, Ryan. So now what we're going to do, so we've looked at edges, we've looked at policy groups, we've looked at zones. Now the other key area of the management console that we need to look at now is assets. All right. So we're going to filter this out a little bit and get some of the extraneous information off the screen again. The filters are your friends, by the way. The filters are always your friends. So what we can see here is, and we're going to pay particular attention to this grouping right here, we can see the 10.20.40.9 BIOS IP address, or again, in routing terminology, the gateway, right? We can see that BIOS IP address is representative of what? The camera and the switch within that zone. So if I jump back to that slide again, we can see there's the 10.20.40.9 address, and here's the switch and the camera that are being protected by the BIOS environment. So looking across the screen here now, as we've expanded those two devices, we can see that BIOS, and this is what Ryan was just alluding to, we could see that BIOS has discovered a bunch of open ports and protocols or resources, right? So we can see for the camera, and let's be honest, the camera's not very sophisticated. We could see that the camera's got port 80, it had port 554, and it had port 1935 open. We could see that the switch had port 22 for SSH, port 80, and port 443 open. So what BIOS did is it discovered these open ports and immediately locked them down. So no traffic can be sent from those ports out of the microsegment or be sent to those ports into the microsegment. So I'm going to demonstrate that for you real quickly. We're going to stop at the slide. And what I'm going to do now is I'm going to bring up this laptop, which is a Windows machine. And that laptop, as you can see, is local to that switch. All right. So I'm going to show you here how I'm logged in locally to that switch, that 10.10.4.47, right? If I jump back to the slide, there's 10.10.4.47, right? And I can show you how I can log into that camera as well, locally, 10.10.4.72, right? So if I want to log into that switch, I am now locally logged into that switch. I have full management access via port 443, but I can only access it from inside of that microsegment. Now what I'm going to do is I'm going to jump over to we'll stop at the slide. We should always stop at the slide. Now what I'm going to do is jump over to this laptop, which is a Mac, and I'm going to try to access that switch again, but this time I'm going to have to access it via 10.20.40.9. Again, I want you to conceptualize a traditional routing environment with how MAC addresses change, IP addresses change, depending on which subnet or segment you're attached to. So by jumping over here and trying to access that switch, you can see I'm accessing 10.20.40.9 right here. But in reality, this site can't be reached. Why can't this site be reached? Well, we showed you with the policy groups, I have the proper layer 2 access. We showed you with zones, I have the proper layer 3 access, right? If we jump back to the slide, lab 1 zone is allowed to talk to lab 2 zone, and lab 2 zone is allowed to talk to lab 1 zone. So layers 2 and 3 are set. I can talk to them at layer 2 and 3. But in reality, until we open up that securely locked down port, I have no access to this switch. So let's go back to the management console, and let's go to the switch, and let's enable that port 443. And while we're at it, you'll see the resources updated. And while we're at it, let's enable port 80 on the camera. Okay, so let's try and access that switch again. Now you can see that via 10.20.40.9, I've now got remote access to that switch.
Jim, do you want to show them the app interface showing your endpoint edges BIOS IP?
Sure, yeah, that's a good idea. While this is loading, let's bring that up. So you can see here that if I choose secure lobby, all right, this is here. Let's always go back to the slide. So here's the laptop. There's the endpoint edge connected to that laptop via USB-C, and we could see that that address is 10.20.30.15. If I jump back to the app, the Byos app, we can see in the secure lobby settings that my Byos IP is 10.20.30.15. So that's where, that's how I'm facilitating this communication. Because I have that address, because I'm in that zone, I'm now able to talk to this switch. Now, I can also launch the camera from here. All right. So you can see now we have very granular and specific controls, both protecting the assets and also facilitating communications to those assets. So what we're going to do now is we're actually going to we're going to perform this system maintenance for this particular piece of equipment. There we go. All right, so now we're performing a software upgrade on that switch, and we're doing it remotely. So we can take a brief look at the camera. And this should be interesting because the camera is pointing right at the switch. And we could see that blinking light right there on the Hirschman device. That's an indicator that an upload is being performed. So I'm not local to that switch. I'm a remote user, a contractor, performing system maintenance, software update on that switch. And here, by logging into the camera locally, I can verify that that update is indeed taking place as we speak. Yeah, go
I
ahead,
think
Ryan.
that's really, I think that's really cool, Jim. I mean, when you look at this versus the rest, right? Like in this scenario, from end to end, you have full isolation of the assets, right? Layer 2 access control, connection to the overlay. Layer 3 access control in the overlay between the zones. Layer 4 access control of what assets, what resources, i.e. ports and services, are actually made visible to that overlay. And there's not a single packet that's being leaked from this entire flow, right? When you look at VPNs, that the connection, the traffic is tunneled with a VPN, but once it gets in the network, broadly, once it passes through that VPN concentrator, it's fair game. Then you're relying on VLANs and a few other things that aren't really security, like VLANs. It's like punching a hole through drywall type of thing.
Yeah.
So and it's pretty elegant.
Yeah, and it's important to point out too that this is not a session-based security that we're talking about here with the Byos solution. This is an ongoing and perpetual security-based solution. So even if you wanted to terminate a specific tunnel for a specific time within a specific resource or application, the BIOS protection still exists through the overlay. So in essence, we're constantly almost in a tunnel. We're constantly providing that protection. So even if we terminate the session, we still have all those ports and protocols, all those resources hidden. We still have all of those assets hidden. So the connectivity, the tunnelization is really just a method of communication within an overarching, much more secure environment. I love your analogy about the VLANs being like punching through drywall. It really is so true. I mean, if all you really need to do to crack a VLAN is sit there, and you don't have to do it. I call it a physical brute force attack. Essentially, you just keep plugging into ports until you find one that's a member of the VLAN you're trying to get into. It's so porous, it's not even funny.
Jim, I noticed something that was pretty cool about the policy that you had set for that JLGW2 device.
Sure.
If you go to it, that policy, if you just put the filter in,
Yep.
I think you're set on routing scenario E, which is which is really cool because you're allowing access from the overlay to the assets inside of that microsegment, right? To that camera and to that switch. But that camera and switch actually have no way to talk to the internet as governed by the routing scenario inside the policy.
Yeah. Good point, Ryan. So I can actually, I'll open up just to show the audience. I'm going to open up an SSH session to the switch. All right, so you can see here, I'm in the command line interface of that switch. Let's just ping Google real quick, if my fingers work. Yeah, so as Ryan just talked about, I'm remoted into that switch. I'm performing system maintenance to that switch from outside the network that switch resides in. Here I am logged into that. I SSH'd into that switch locally, and you'll notice that if I try to ping, just ping a Google server, the Google DNS server, I can't get to it, right? So I'm performing system maintenance on an asset that has no portal to the outside world on its own. So, this piece of equipment, and listen, there's no bulletproof scenario or bulletproof solution where everything is 100% protected all of the time, but we're doing risk mitigation here. And if you think about it conceptually, I'm secured behind a Byos endpoint edge. I'm connected to the secure lobby overlay through that endpoint edge. The switch is connected to a gateway edge, which is connected to the secure lobby. So my contextual conversation with that switch is unidirectional. I can talk to the switch. And let's check it, by the way. And I can update that switch's software remotely, but that switch cannot go out unabated and potentially pull some sort of infection or malware into the environment. So, it really is so granular and so specific and such tight, strong security. It's incredible. It really is. So then you can see here, the software has successfully updated on that rail switch. So if I click OK, you can see the stored version is 9.2.0.0. The backup version is 9.0.0.5, and the running version is 9.2, right? So I've already updated the firmware on this switch. And if I go back over here and I look at the switch, let's close the SSH connection. If I go to the software here, right, you could see that it's reflected, the update has taken place. There's the stored version, 9.2.0.1, right? And the running version is 9.2.0.0, just like it is in the remote connection. So if I now do a cold boot on this switch, either locally or remotely, the switch will then reboot or boot up in the new, most updated firmware. So I don't know, Ryan, did you have anything else you wanted to add to the demo?
Yeah, I was actually going to say, I was going to say you should change the policy of that group to actually allow internet access, and then show just how fast that policy gets pushed.
Yeah, good call. That's a great idea. So we're going to switch from in external network scenario E, which has no internet, and we're going to switch to D. We're going to click save, right? This is so complex and complicated. We're just going to click save. That policy is being updated as we speak. You'll see here, policy has been updated. All right. So now let's jump back over. Let's SSH into that switch again.
That was your alert to say that your routing scenario was updated, Jim.
That's correct. Yes, it was. And now if I click return and I go to ping that Google DNS, now we have connectivity to the internet. So yeah, really is a very powerful solution. And I think it's as powerful as it is because it's not so complex and complicated. It's very intuitive. And and this is for all the traditional networking people out there, once you conceptualize that the overlay and the zones and the policy groups is all of the traditional networking environments that you're used to, but with all of the protections and protection mechanisms built in. You really, it's such an intuitive and clean solution. It just makes all the sense in the world.
Awesome. Well, thanks for giving that demo. I think to recap, we've got one more slide, so we'll pass it there, and we'll just tie it back into the use case. I think there's three main categories in which Byos adds value for a customer. This demo, we focused a lot on defense in depth, the capabilities that we offer through our platform, isolating assets onto their own microsegment so that they're invisible to the rest of the network, the different layers of access control, and the ability to, granularly enable access to specific resources. Like, that's a very novel capability that not a lot of other vendors have on the market today. But when we look at the return that customers achieve by deploying our solution, the cost savings from a VPN takeout, that's huge, right? There's a lot of other business related benefits that Byos offered. We can reduce the amount of cabling costs that you need to have on your plant floor to wire up your equipment so that they can receive networking, right? We add wireless capabilities to those perhaps legacy controllers so you can be more flexible in how you set up your manufacturing floor, right? If you can now collect data on the plant floor more effectively, right, you're not going to need as many truck rolls of technicians on site to perform basic troubleshooting and maintenance. When you look at a larger manufacturing operation where you have multi-location and multi-site operations, right, you now have that 100,000-foot view and the 1-foot view of, okay, what's exposed in each of the networks and how do all of my assets talk to each other. So all in all, I think there's both security and operational benefit to the Byos solution. And we're glad that you guys watched along today. So thank you. So if someone watching this has a question, how can they reach you, Jim?
Glad you asked, Ryan. So here's the contact info for both Ryan and myself. And we're here at Byos. We think it's very important that we understand, we have a conversation with you as a customer. We understand, what are your goals to achieve a better security posture? What are your pain points? What are some of the issues that you're struggling with? And we would like to collaborate with you, on looking at your network architecture, seeing where we could potentially fit, and possibly provide you with a solution.
Awesome. So stay tuned for our next video, which we're going to be demoing how Byos is applicable for connecting to legacy devices on the plant floor setting. And we'll probably walk through how to activate and deploy a Byos Edge and to actually set up your network. So thanks a lot, and we'll see you soon.
Thanks, everybody.